Among the vast theater of the night sky, where stars shimmer like distant beacons across the black velvet of space, few celestial bodies have managed to captivate the human imagination as powerfully as Betelgeuse. This iconic red supergiant, nestled in the shoulder of the Orion constellation, has stood out for centuries not only because of its vibrant, unmistakable crimson hue, but also due to its sheer enormity. It is a stellar giant that dwarfs most other visible stars and demands attention even from the most casual stargazer. For generations, Betelgeuse has been a source of wonder, its beauty and scale inspiring countless myths, studies, and sleepless nights beneath telescopes. Yet recently, it has thrust itself back into the spotlight, not merely for its visual allure, but due to a startling transformation that has sent ripples of excitement and curiosity through the astronomical community. The James Webb Space Telescope, with its unparalleled ability to peer into the hidden layers of the cosmos, has detected a staggering 250% surge in Betelgeuse's brightness. A sudden, dramatic escalation that has raised eyebrows and fueled speculation across the scientific world. This unanticipated spike in luminosity is not merely a fascinating quirk. It may be a clue, an urgent whisper from deep space hinting that the star is undergoing profound internal changes. Betelgeuse isn't just any star. It's a red supergiant, a colossal stellar elder nearing the final act of its cosmic journey. Positioned roughly 642 light-years from our planet, it ranks among the most massive and radiant stars in our galaxy. Its diameter so vast it would extend far beyond the orbit of Jupiter if placed at the center of our solar system. Outshining the sun by more than 10,000 times, this celestial titan lives in constant turmoil, its interior roiling with convective currents, and its outer layers shedding mass like whispers of stardust into the vacuum. Such stars are notoriously volatile, prone to erratic dimming and sudden flares of brilliance. Yet this most recent brightening episode is unlike anything seen before. So sudden, so pronounced, that it could mark a pivotal moment in our understanding of stellar death. Thanks to the James Webb Space Telescope's cutting-edge infrared instruments, scientists were able to penetrate the dense cloud of gas and dust enveloping Betelgeuse, revealing a scene of immense dynamism. The leap in brightness occurred within just a matter of weeks, a rapid shift that challenges conventional models of stellar behavior. It suggests that Betelgeuse may be hurtling toward a new and more unstable chapter in its life, a chapter that might culminate in one of the most spectacular phenomena in the cosmos, a supernova. For years, astronomers have anticipated that Betelgeuse could explode within the next 100,000 years, a blink of an eye in cosmic terms, but now the question looms larger than ever. Could that moment be much closer than we imagined? While it is impossible to predict with certainty, the current behavior of Betelgeuse is difficult to ignore. The star has a documented history of erratic brightness fluctuations, including a dramatic dimming event in late 2019 that puzzled astronomers and stirred public fascination. But a 250% increase in brightness suggests a dramatic internal event, a possible precursor to collapse. Should Betelgeuse detonate in a supernova, the resulting light show would be utterly awe-inspiring. It would rival the moon in brilliance, visible even during the day and dominating our night skies for weeks or even months. Despite this fiery demise, Earth would remain safe from harm due to the great distance separating us from the blast. Yet the observational opportunities such an event would provide are beyond measure, offering a rare front-row seat to the death of a massive star. This uptick in brightness is not just a signal of potential catastrophe. It's also a puzzle laden with scientific intrigue. Red supergiants like Betelgeuse are inherently complex, their vast and turbulent interiors filled with mystery. Understanding what triggers their brightness fluctuations could unlock answers to some of astrophysics' most persistent questions. One leading theory proposes that Betelgeuse may have recently experienced a colossal convective upwelling, a massive bubble of hot gas surging from the star's core to its surface. Such activity can displace enormous volumes of stellar material and dramatically alter the star's brightness, temporarily flooding the surrounding space with enhanced light. Alternatively, Betelgeuse may have undergone a significant mass ejection, creating an expanding cloud of dust and gas that, as it interacts with the star's radiation, results in a surge of visible light. This could even be the aftereffect of the mysterious dimming event from a few years ago, now reversed as new stellar material is expelled and illuminated. Some researchers also suggest that Betelgeuse's complex magnetic field may be influencing these changes in unexpected ways. While not yet fully understood, the magnetic behavior of red supergiants is emerging as a key factor in their late-stage evolution. Fluctuations in magnetic activity can disrupt energy flow within a star, potentially leading to sharp variations in brightness. If Betelgeuse is indeed undergoing a magnetic shift, the resulting disturbances could help explain the current luminosity surge, opening a fascinating new chapter in the study of stellar magnetism and its role in cosmic evolution. Equally important is the phenomenon of mass loss in these final stages of stellar life. Red supergiants lose material at astonishing rates, and this outpouring of gas and dust contributes significantly to the star's transformation. If Betelgeuse is now shedding its outer layers more aggressively than before, this may signify that the star is approaching a structural breaking point. The instability triggered by such intense mass loss could be the harbinger of collapse, initiating the sequence of events that ultimately culminates in a core implosion and supernova explosion. For astrophysicists, the opportunity to track these developments in real time using the James Webb Space Telescope is nothing short of a scientific treasure. The telescope's ability to capture high-resolution, infrared imagery enables astronomers to monitor Betelgeuse's behavior with unprecedented clarity, revealing subtle shifts and complex patterns that would have remained hidden with earlier technology. As Betelgeuse continues to shine brighter than it has in recorded memory, astronomers are watching with bated breath. The star's current state does not necessarily mean an immediate supernova is imminent. Red supergiants are famously unpredictable and can undergo dramatic changes without leading to their explosive end. Nevertheless, this extraordinary brightening event is impossible to dismiss. It signals that something monumental is unfolding within the heart of this ancient giant, a cosmic drama whose final act may be closer than we dared to believe. Whether Betelgeuse explodes tomorrow or 1,000 years from now, its recent transformation is already reshaping how we understand the lives and deaths of the universe's most massive stars. This is not merely an astronomical curiosity. It is a living narrative of celestial evolution, unfolding before our eyes in the dark theater of the cosmos. Understanding the intricate behavior and internal dynamics of stars is not just a pursuit for astronomers seeking knowledge for its own sake. It's a profound journey into the very processes that sculpt the universe itself. By studying the enigmatic fluctuations of stars like Betelgeuse, we unlock vital clues about the grand mechanisms that govern not only their birth and evolution, but also their dramatic ends. The recent, startling brightening of Betelgeuse acts as a celestial wake-up call, an emphatic signal from deep space that reminds us how chaotic, powerful, and unpredictable the forces at play in our cosmos truly are. Far from being static or lifeless points of light in the sky, stars are vibrant, dynamic entities, constantly shifting in behavior and form as they undergo complex evolutionary transformations. Betelgeuse, with its sudden and pronounced increase in luminosity, has offered us an unparalleled window into the violent and fascinating internal processes of red supergiants, a rare opportunity that scientists are eagerly dissecting with every tool at their disposal. This spectacular star, now under constant observation by both space-based and terrestrial telescopes such as the James Webb Space Telescope and a network of ground-based observatories, is being monitored with a level of scrutiny rarely afforded to a single celestial object. This real-time tracking is expected to yield a wealth of data, shedding light on the still mysterious forces behind the star's recent behavior. As months pass and new readings are analyzed, astronomers hope to determine whether this brightening is a transient fluctuation, a hint of an impending collapse, or a new chapter in the already unpredictable narrative of Betelgeuse's life. And yet, this phenomenon does not concern Betelgeuse alone. Red supergiants like it are scattered throughout the universe, and understanding this one star could hold the key to deciphering the life stories of countless others. By decoding the shifts in Betelgeuse's brightness, researchers may soon be able to generalize these lessons across the broader stellar population, deepening our comprehension of how such immense stars transform and ultimately meet their fates. What makes this sudden astronomical development even more compelling is the way it bridges both the deeply technical and the beautifully existential. It doesn't merely enhance scientific theories. It ignites wonder and awe in those who gaze skyward and wonder about their place in this vast, unknowable expanse. Betelgeuse has long occupied a special place in the sky and in cultural lore, often linked with the mythical figure of Orion the Hunter. Its current behavior, so volatile and mesmerizing, adds new chapters to its legend, capturing public imagination as much as scientific interest. There's something almost poetic in watching a giant of the cosmos tremble, a star on the verge of transition, uncertain whether its next act will be a dramatic supernova or another baffling phase of luminous transformation. The 250% surge in brightness, as recorded by JWST, has sent shockwaves through the scientific community, upending expectations and sparking new debates about how such titanic stars function at their core. It forces astronomers to reevaluate long-standing models of stellar behavior, particularly during the final stages of a supergiant's existence. What mechanisms inside Betelgeuse could catalyze such a drastic leap in light output? The answer may lie in the extraordinarily complex dance between gravity, nuclear fusion, and magnetic fields, each a vital player in a star's life, and each capable of creating monumental shifts in stability and output when thrown off balance. Betelgeuse, like other massive stars nearing the end of their fuel reserves, undergoes turbulent internal changes as it attempts to fuse heavier and heavier elements. These processes become increasingly unstable, and once the fusion can no longer counteract the immense gravitational pull inward, the countdown to collapse begins. The dramatic brightening may well be a sign of deeper convulsions taking place within its core, a reaction to the star exhausting lighter fuels and moving into a phase of fusing heavier elements. As the core contracts, the outer layers may expand or be violently ejected, producing the intense luminosity that has recently stunned observers. This outpouring of energy, possibly accompanied by significant material loss, might be an early indication of the chaotic road leading to a supernova explosion. But just as plausibly, it could represent yet another twist in the unpredictable saga of this colossal star. What's especially intriguing is the role mass loss plays in this spectacle. As Betelgeuse continues to shed layers of gas and dust through stellar winds, the way this material interacts with its light can create both the illusion of brightness and moments of dimming, depending on how the surrounding material refracts, absorbs, or reflects the radiance emanating from the star. This intricate interplay of mass loss, fusion, and stellar instability paints a portrait of a star in flux, one that could explode in a blaze of cosmic glory or continue its erratic path for centuries more. Whatever the ultimate outcome, this event marks a significant milestone in our quest to understand the final acts of massive stars. The ability to witness such changes, possibly leading to a supernova within our lifetime, is both exhilarating and humbling. It raises questions not only about the mechanics of stellar life and death, but also about the larger tapestry of existence that connects every atom in our bodies to the hearts of stars like Betelgeuse. So while we may not yet know whether this surge in brightness signals Betelgeuse's swan song or a temporary flare in a life marked by unpredictability, it undoubtedly underscores the dynamic, evolving nature of the universe. It invites both scientific scrutiny and wide-eyed wonder, beckoning us to keep watching, keep questioning, and never lose our curiosity about what secrets the cosmos still holds. The skies are alive with stories waiting to be told, and perhaps, in Betelgeuse, we are witnessing the prelude to one of the most spectacular tales of all.